All right, let's get started. I'll just stop the share. All right, hello everybody. Thank you for joining us for the very first ever Data Squad. For those of you who don't know much about Data Squad, Data Squad is a program where Mike and I are joined by experts from the industry to walk through solutions to your big data challenges. Data Squad is meant to be interactive, so if you have questions or comments, please either raise your hand and keep yourself muted or stick them in the chat and we'll get to them. So why don't we go around the table and introduce the hosts for today's Data Squad to start us off. My name is Ethan Newman. I'm an applications engineer here at Alter, and I'll kick it over to Mike.
Hey, my name is Mike Kravik. I'm a solution architect at Alter, and I work with lots of customers on different kinds of data protection and control needs. And I'd like to pass it over to Dan, and I can't see him on the camera, so where are you?
Hey, everybody. My name is Dan Hemminger. I'm a senior consultant with Apititive, and I'm really looking forward to this topic today. Glad to be here.
And my name is Nick Suarek. I'm a consultant with Apititive as well, working alongside Dan, and I'm also very excited to be here.
Great. So let's get started. So the topic today is tokenization versus encryption, and as well as hashing. So a quick poll for everyone. Feel free to put as much comment and detail as you'd like, but if you're using any of those three, tokenization, encryption, or data hashing, feel free to type that in. Or if there is any other kind of questions that you may have, we'd love to hear them, and we'll see if we can weave them into the discussion as we're going through our a little bit of presentation and a whole lot of demo. So we'll give people time to do that. But while we're doing that, I would like to just get into some detail about, and I'm looking for my control screen on Zoom. There we go. I actually know what I'm doing. Let's see. There we go. Always the wrong screen. So let's just talk a little bit about these three topics, whether it's tokenization, encryption, and hashing. You know, all three of them, the intent is to protect the data while it's at rest, where they get stored either in a database or other locations, but they each have their own powers and weaknesses. And instead of just going through a standard kind of truth table, I'm just going to leave that up here and just wanted to give you an idea of some of the things that we've been seeing from customers. And the first one that I see talking to customers is a lot of confusion between tokenization and encryption, and even a little bit of hashing. And the differences are pretty stark if you look at what we have on the two columns. From encryption, you're encrypting it. It's like that just like you've always encrypted data, whether it's files or communication, web traffic, it winds up having a key. And if you have the key, you're able to see everything. The difference with that and tokenization is tokenization actually doesn't have any mathematical connection between the data and what the token winds up being. And the real data gets stored in the vault. It's important to really be aware when you're talking to vendors about what really the math and the science behind the vault, because that's really where all of your key data winds up being, and that's really important. And maybe that's a topic for another day. But the other interesting part about tokenization is you can actually use the data. So it's very much like what you could do with hashing. Hashing is a one-way function where you're always going to get the same result. So instead of Mike Kravik, you get blah, 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 and you can use that blah, blah, blah in joins and other kinds of lookups and other types of operations. Tokenization can do exactly the same thing. That's called deterministic tokenization. So there's a determinism as far as what the original value is, as well as what the resulting token winds up being. Hey, Dan, do you have any customer stories that you wanted to share, or any other kinds of topics that other customers have
Well, I mean, I think I'm excited about the tokenization, especially like I keep coming back to the fact that it remains operational, because that's one of the challenges, aside from just having so many different endpoints of data, different use cases, trying to manage all of that separately. Being able to go through one sort of tokenization service to do that while keeping the data operational is just like, it's really important. I think, really I would love to get that message out to my clients, because I mean, it's such a hard topic to broach with them. So so no, like we haven't gotten to specific cases yet, because they really haven't started addressing it at that level for the most part.
Okay, let me I have a couple of cases. There's really two. I can take all the cases that we talk to customers about and really bucket them into two subjects. One is end-to-end tokenization with respect to migration of data. And the big issue is your companies are going through a digital transformation. They are taking data to the cloud. And they also are hiring people. They're outsourcing all of that migration work. So now they're actually taking the data crown jewels in their large database, and they want people to take it in mass and bring it up to the cloud. So in order to safe that off, they'll tokenize the data in their on-prem database, and then they can essentially give it to anybody, because it's not useful data unless you detokenize the data. And most customers will take that data, put it up in the cloud, and then they leave it tokenized, because the solutions today actually respond really quickly to these detokenization events, where you can keep the data tokenized for as long as possible. So not even that last mile, that last foot. When those queries occur, detokenize on the fly and then send those values back. So that's one of them. The other one is still trying to keep data tokenized, but there's lots of people using the data for various reasons. And this is typically data science workloads, marketing workloads, where lots of people are touching potentially sensitive data, and they're tokenizing it so that they don't have to create multiple copies or secure views or other kinds of data engineering gymnastics that would reduce the risk and still keep the data in plain text. So you can take those key points, those key columns, tokenize them, and then just use it like you normally would. And then again, at that last moment, even if it's not necessary, detokenize if you need to or not. There's a question in the chat about the 100% read audit encryption. Thanks for picking that up. Really what that comes about is when people are detokenizing or decrypting data, the read auditability is being able to see if somebody was able to detokenize or decrypt, how much data were they able to see. So when you're talking about encryption and decryption, you're going to have to assume they could have looked at anything or exfiltrated anything. With tokenization, you have to go, there's no one key to detokenize all your data. You have to go back and either in bulk methods or one by one, ask for detokenization. It's like going to coat check. You've got your little ticket and you're going to have to get your coat. You just can't go and take the entire coat rack like you can with encryption. Right. So that's why there's two different levels of auditability. Was there somebody piped in with a question?
No, Mike, I was just going to say, it's like just thinking about like at the database level, having a database key for encryption, right? So then that key gets breached, and then you just have to assume every single data point in the piece of data in the database has been read in common.
Yeah, exactly. So it's really a matter of after the fact, what kind of auditability do you have? And what, at least the way we look at it from our perspective is there's two aspects to, really having to know how you use your data. And one of it is, well, what happens as people are using it, and what's that audit trail, and what's happened with the system, what's happened with queries and data access. And that actually gets very deep very quickly. And so having fine-grained controls or fine-grained information about that's pretty important. But I think we've done enough talking Let's see. Hey, Ethan, are you ready for our like demo mode, you and Nick?
I am ready. I'm
All
excited.
right. So along with that, I'm going to have to change my background, and I'm going to stop sharing.
Okay, awesome.
And while you're getting ready, I will get ready too. And now let's get into demo mode.
Perfect.
Where anything could happen.
All right, so just to give you guys a brief overview of what we're going through in this demo, we're going to go from 0 to tokenization in 15 minutes or less. So we're going to start completely fresh and create some tables with some dummy data in there. And then there are two main players in this tokenization effort. There's in Snowflake, there's an external function, and that external function is basically sending out data to an external point. And then there's also the tokenization API. So I'm using Alter's tokenization API for this. So there's an intermediate step here, but the gist of it is the external function is going to send that data out to the tokenization API, and then it gets tokenized, and they send back tokens to Snowflake, and then those tokens get updated into that column that you specify. So let me go ahead and share my screen, and we'll get started on that. Okay, so the very first step we're going to do here is create a couple new tables, one called Data Squad and one called Data Squad 2. And the column that we're going to tokenize in each of these is the social security number. So I'm going to create those tables real quick. And the reason why we're doing 2 is so we can show that even after this data has been tokenized, it's still, you can still operate on this data, so it's still valuable. So for example, let's say I tokenize this social security number in this first row. This next one matches it here. So that'll give us 2 matching tokens back, and we can use that for anything from where clauses to joins. So you can still use that data even though it's tokenized. You have no risk because you can't actually see those plain text social security numbers. Okay, so I'm gonna insert some data in here. I've got about 15 rows of dummy data here going into Data Squad 2. I've got emails and social security numbers. And then I've got about 1,000 rows going into Data Squad. And I've got first names, last names, and social security numbers.
And just really quick to add, just imagine while Ethan's doing this, that you've got, this customer data up in Snowflake, and you've got a group of business users that need to access this data for, XYZ. And then this would be like one of those ways you could say, okay, let's tokenize it and then allow them to still see the data that they need to see.
So operate with it, yeah.
So the next step is going to be actually creating that external function. And there's an API integration that goes with that. So in Snowflake, we're creating an API integration which holds the information about that endpoint that we're going to be accessing, and then the external function actually calls that API integration. So while I create these two, I'm actually going to pause because we've got just some AWS ARNs and other stuff I'm going to insert in there, and then I'll show you guys a template of what these actually look like, but just give me a second to insert these in here.
Yeah, we definitely have to err on some level of security because we don't want to show you where our buckets are and whatnot, but to let Ethan take care of that. While that's happening, any questions or comments as we're taking this data and getting it tokenized?
Hi, this is Jennifer Ray. I just had a question. So it's been a little while since I've worked with an organization set up an external payment portal, basically, and so it wasn't us directly doing the tokenization.
Hey, Jennifer, my apologies. Your audio is pretty bad. Feel free to continue asking the question, but if you can, throw it in chat just to make sure that we get the right information. I want to make sure we address your question.
Sure. Thank you. I'm going to switch to phone. Hold on.
Yeah, no problem. Yeah. while we're waiting for Jennifer to come back on audio, were there any other questions? Feel free to unmute yourself and ask away, and we'll see what we can do to answer your question. How about a quick poll while we're waiting? How many people are using Snowflake or Cloud Data Warehouse? If so, throw your vendor of choice. I'd love to see that information.
Okay, while we're waiting on Jennifer, I'm all set. So I've done a couple of things, and Jennifer, if you get your audio working, just interrupt me and we can take your question. But I've created this API integration called Snowflake Tokenize, and it just has this endpoint here. So I did mention there was an intermediate step between the external function and the tokenization API, and that middle step is a Lambda in AWS. And all that Lambda does is some formatting on the data, because the formatting of the data that Snowflake passes in versus the formatting of the data that the tokenization API wants is different. So all that Lambda does is takes that data and converts it to the format that the tokenization API wants. So that's sort of like the middleman here. We've also got this external function called alter tokenize, and that uses its API integration and calls the tokenize method here. And now that we've got these external functions, we can just go ahead and run them and do some tokenization. We're just going to do some updates here. So we've got update data squad and data squad 2, and we're going to tokenize the social security number column. So let's just go ahead and do it. Give it a few seconds here. There we go. We can see that the number of rows, 1,000 rows have been updated in this first table, and then I'll run this on the second table too. And then we can see what these tokens actually look like. So this social security number has been tokenized, and this string here means nothing. So your data is protected. You can't see those social security numbers. Go ahead, Mike.
Let me stop you there, Ethan, for 1 second. I noticed Jennifer's back on phone. So if you don't mind, feel free to ask that question again.
Sure. Sorry about that.
Oh, no worries.
For some reason, my computer is not, it doesn't like Zoom audio for some reason.
It is all part of the day, isn't it?
Well, I was saying that, so in my organization, we set up an external sort of payment portal that customers could issue payment. And of course, there's some information that needed to be exchanged that needed to be tokenized because we set it up through an external application, basically. So in that case, you know, it was a heavy learning curve for those of us because we had never set up something like this before. There was limited knowledge, and we were trying to find, I guess, regulation on, you know, how you should protect certain types of data. And at the time, it seemed like, you know, what regulatory side of things wasn't keeping up with the rate of like this sort of digital transformation. And I just wondered, and I'm sorry, this was more like, you know, it's not really related to what we're talking about right now, but I was curious if lately, like from a legal standpoint, if there's more precise regulation on how to protect customer data and what needs to be protected and that kind of thing.
Mm-hmm. Do you have any kind of PCI requirements, HIPAA requirements?
Well, yes, both. From an HR standpoint, there was some HIPAA, and then it was PCI. So that's what we saw was PCI for the most part, but it felt like it wasn't necessarily directed toward, you know, like online payment collection. And I just wondered if there'd been any development there, or if there's any representation for. Go ahead.
Yeah, so that really comes down to how the data is stored in the token vault. And that's where your plain text data gets stored. Just to, I mean, I can speak more toward Alter from our offering, but you're definitely going to see different capabilities from different vendors. But what we do is we'll shard that data out. So let's say it is a social security number. So the first, 3 numbers go to one location, next couple of numbers go to another location, and it gets split up. And the whole point of that is that it gets, since it's sharded and then encrypted in its storage location, it's not really identifiable information anymore. So that's one of the reasons why tokenization is a much better solution. So kudos for you for taking that route as opposed to just encryption. So hopefully that gave you a high level answer.
It did. Thank you.
Okay, great. So back to you, Ethan. So thanks for taking a quick pause for Jennifer's question.
No worries. So the last part of this is I'm going to show you a join on these 2 tables on those, since they have matching social security numbers. Nick, do you want to talk a little bit about that while I type that up?
Yeah, I was just going to mention it. I know we've been kind of harping on the fact that the data is still operational after we tokenize, in this case, the social security numbers. But that goes back to kind of Mike's point at the start of this conversation of that deterministic tokenization, how we can still, again, even when it comes to joins, we can still use the data.
Awesome, thank you. So those first 15 social security numbers were matching between the 2 tables, so we can perform a join on those even though they're tokenized. So this join here, we just have the first name, last name, and then from the second table, we get that email, and then we're going to join them on this social security number, on that tokenized social security number. So we'll see what that looks like. All right, here we've got the first name and the last name from the first table, and then the email from the second table, and then it's joined on this social security number. We're tokenized. Oh, Mike, are you muted?
Yes, I am muted. Thank you for that.
Mm-hmm.
Yeah, so we're tokenized and we're operational, which is really neat. Another quick question to the group. Well, is it a surprise that tokenization is still operational for data that is tokenized can still be operational? So please throw your opinion in there. Thanks a lot for that, Kim. Anyone else? So James brought up a really good point. So it seems similar to hashing. Can I get plain text values back if I need them? Yes, we absolutely can. And
we can do it right now.
It looks like Ethan already has that set up. So let's
I do.
let's see how that works.
All right. So all we're going to do is call this other external function we set up called alter detokenize. That's just going to send these tokens to Alter, and then Alter will send back the plain text values. So we'll go ahead and do that. And the cool thing about this is you can set this in a masking policy. So you can say in that masking policy when somebody's a certain role, then call that external function alter detokenize. And so you can do it query by query. You can say, is this person in the correct role or something of that nature? Go ahead and detokenize. So we'll
yeah, and while that's happening, so what Ethan just did was really a bulk detokenization, but we can you can detokenize really on the fly as well. So that last mile of data is protected all the way to the point where the query results get returned.
Right. Okay, so here we have these plain text social security numbers that have been updated from that external function.
Now let's see. I think we timed this out pretty well. So I'd like to thank the Apititive team, Dan and Nick. Is there anything that you wanted to bring up to the group before we all finished up for the day and let everybody get back to the rest of their Friday afternoons?
No, I appreciate the time today. It was good joining you. Thank you.
Yeah, thank you. Thanks, everyone.
So to the group, Ethan, did you have the next steps part? My apologies. This is part of the growing pains of just learning, just doing this for the first time.
I believe
So
that was you.
yep, it is me. So again, if you have any questions or challenges, we'd love to hear other things that you'd like to have us do. Then also, as far as if you are interested in what we were showing, you can go on our website. You can get started for free for Alter, especially with Snowflake. So you can just sign up there, sign up through Snowflake's Partner Connect. And anything else that you'd want to hear from us, please send us a message. And thank you all for coming. And thanks for your questions and your attention. If there's any other final comments, feel free to unmute and check them out. All right.
Thank you very much for your time today.
Oh, you're welcome.
Thank
Great
you,
meeting.
everyone.
Thank you.
Thank
Hey,
you.
Great.
Take
Have a
care.
great weekend. Bye-bye.
Awesome. Thanks, guys.